other ones. I've got a battery here. I've got a battery. Boop, boop, boop. It's 12 volts. I've got a resistor over here. That's 5 ohms. It comes back over here and then does something called a Wheatstone bridge. 10 ohms. Wheatstone bridge. Don't worry about it. You don't need to know. Do not put that in your permanent memory. It's not worth it.
Are you just making up the problem?
No, I'm doing the example problem in the back, right underneath Kirchhoff's laws, rules which you're supposed to write down.
Yeah.
Okay.
All right. That's kind of vicious. That's fine.
Whoop. Oh, I need a resistor there. This is 1.0 ohms and 1.0 ohms, and then I'm back into the battery. Says, what is the power delivered from the battery? What is the potential difference between A and C? Point A and point C. Here's point A and point C. There's no two sources. We're going to do it for a single source, and then we'll do two sources later. There's two sources later on. We don't have to. Could we do this the other way? Painfully, we could do it, right? We could gather this up and say, okay, these are two, and these two are in parallel. This is in parallel with this. These two are parallel with this system here. So we count these together, right? And then we'd say that this is in series with this, which is in parallel with that. And we could certainly do it, which is a series with this, and we could absolutely do that. No problem. I'm not trying to overwhelm you with that. That's actually doable, and it's actually reasonable in this case to do it that way. Okay. I'm probably not going to choose to do it that way because I'm playing a game with you right now. Okay. Mostly, it's the second question I want to get at. Second question I don't think I can answer with the old stuff. Does that make sense? With the voltage drop is across there. So let's start off with what Kirchhoff's law said. Kirchhoff's law says I'm going to start establishing what the current is in any one of these wires. Do I know the current anywhere? Nope. So I'm going to start labeling it out. I'm going to call this I1. I'm going to assume it's going this way. It has to have a direction. It could go the other way. So this is the positive in the battery, negative in the battery. So it is going that way. But okay, but current is the positive flow of charge. Therefore, although the real things are going this way, in AP physics land and physics land everywhere in the United States, theoretically we imagine the positive flow of charge. Feel free to thank Ben Franklin for that. I'm totally, again, you guys are, it doesn't matter. They went 150 years without realizing they were doing it backwards the whole entire time. No idea. They were doing circuits, they were building stuff, things were happening, it was great. And then somebody said, well, it's all backwards. And they didn't change it because we're lazy and that's what we do. We don't change things. Old people don't, positive flow. We're good. Okay, because there's no positive flow. So he's correct. And by the way, don't let that confuse you. On the AP test, on the very front page, on that thing, current is the positive flow of charge. It's like, there's no positive flow. It's really electrons going the other way. But we're going to do it that way. Okay? So far, so good? Okay, that's I1. So this is going to be what? I2, let's call it. I'm going to say it's going to go that way. Let's call this I3. It's going to go that way. I got I4 going that way. By the way, it's the same as this one right here. So that's I4 as well. And I got I5 right here, right? I5 that way. Okay? Okay, so what Kirchhoff provides is not an easier way to do the problem. It provides a way to do the problem that is, this is the way to do the problem, do the problem, do the problem. Okay? So first thing is I established where all the I's are. Now I'm simply going to write all the voltages and all of the conservation of currents. Okay? So what do I mean by that? Okay, let's start doing this. Let's start off with well, I2 must be equal to what? I4 plus I5, right? I2, I4 plus I5, right? That's 3 unknowns, man. We're not done. No way. Why not? Pick a different one. Give me another one, Natalie. I1. What's I1 equal to, Natalie?
I2, and I can't see you.
I2, this is I3. Good job. Give me another one. All right, now I have 1, 2, 3, 4, 5 unknowns and 2 equations. Give me another one. That's an identity reaction. Actually, it's I3 plus I5 plus I4 must equal I1, right? I3 plus I4 plus I5 must equal I1. Woo! Loving it. 1, 2, 3 equations, 5 unknowns. Need 2 more.
Four. We do have 4.
What do we need this thing? We need, I don't have an I have I5 in here already. What do I have? I1, we did I1, I4, no. No, I5, I2, what are we missing? We're missing something. I3, I1 become I2 plus I3, got that. Okay, well then let's start doing some loops. We got to do both anyway, so we might as well do them. Give me a loop. Give me a starting point and tell me what my loop's going to look like. I mean, starting here.
See all the way around.
I want to go all the way around the loop. Big one, small one, doesn't matter which one you want to do. Let's do the big one, like this. Like that. Cool, let's do it. So, wait, what?
You want reverse voltage.
All the way back to C. What we're going to do? We're going to go all the way back because when I get to where I started, my voltage has to be what?
Oh, but that's not the way to connect.
No chance of that. I'm talking about going down the hill and then back up the hill, the waterfall. Right? So I'm going to do that one. So I'm going to do I2 times, what was that? I can't read. 10, 1, 1, 10. That 1?
That's 1.
That's 1. Okay, so I'm going to do I2. So I'm going to say 0 is equal to, because I'm at 0 voltage when I'm done, negative, I'm going to voltage drop, I1 times 1. No, I2 times 1, my bad. That's 2, right? Plus, actually, just do it down here. Let me give a little room here. Negative I2 times 1. Second part of the loop. Going through here. I'm going to drop voltage here because current's going this way, so I'm going to lose voltage going across that one. What is it going to be? Negative I4 times 1. Minus I4 times 1 again, because we're going to go back through this one up here, right? Now, I'm going against the current here. So I'm going up against the waterfall. So plus I3 times 2. 4 equations. One last equation, and I need to include the battery on this one. Give me one for the battery. We're going to make a loop with C, and we're going to go through the battery, right? I'm going to go from the bottom to the top, which is that's going to be uphill. I'm going to gain 12 volts going across that way. So I'm going to start here, going this. Now I'm going the right way this time with that. So I'm going to have 0 is equal to, I'm going to have negative I3 times 2 plus 12, because I went uphill, minus I1 times 5. 5 equations, 5 unknowns. You could do this by isolating a variable, plugging in the other 4, then isolating a variable, plugging in the other 3, isolating a variable, plugging in the other 2, isolating a variable, plugging in the last one, and then you got 1, and then you start working your way backwards through the system, and you get all the different currents. What do you mean? I take my word for it. I should make every student, every class do this. But last year, I taught my trig class something I hadn't taught my trig class in years, which is how to solve a 5 equations, 5 unknown problem. You can actually do this with your calculator. in matrix
Oh,
mode.
yes.
Remember matrix mode? If you put it in matrix mode, let me show you how to. Now, if you don't want to do it, your other option is what?
Group R.
5 equation, isolate, isolate. You're going to have to do it. I don't mind if that's what you want to do. I'm not going to stop you. In fact, that's the way I taught it all the way up to this year. This year, since I taught the other skill, I thought, well, maybe I'll just do it. You got a simultaneous at the end, do 5?
Yeah, I got one too.
You can go to 10.
With 5 equation unknowns?
Nice.
Yeah.
Well, then do the simultaneous equation fine. I don't know yet.
Oh, really?
Well,
Well, it's AP Physics. We don't care how you do the math.
Oh, okay.
Give me some way to do the problem.
wait, we have
Okay.
5 unknowns now?
Yeah.
I'm gonna set it up as a big matrix. That'll teach me a lesson. I'm gonna do 0. I'm gonna do 0 plus -1 I2 plus 0 plus I4 plus 0 plus that. Oh, no, not 0. I5.
Like the cool one or the
I'm gonna go that way. And then I'm going to go -I1 plus I2 plus I3 plus 0 equals 0. Next equation can be written as, I better make sure I wrote this right. 3, 4, 5, I3. That doesn't look right. This is I3, this is I1. So that would be I1 is plus 0 plus I3 plus I4 plus I5 equals 0. Next one would be 0 minus I2 plus 2 I3s minus I4, minus 2 I4s plus 0 equals 0. And the last one would be -12, -I3, 2 I3, 5 I1, plus 0, plus 0, plus 0. So that would be that way. I would approach it using the stuff I taught you last year. I'm going to go find my calculator.
Wait, why do we have 2 equations for I1?
There's lots of ways to try ones.
No, in our beginning set, the I1 equals I2 plus I3.
Yeah.
Then I3 plus 4 plus I5 equals I1.
Yeah. Because so this one is I1 equals these two.
Mhm.
This one is this plus this plus this equals that one. I'm moving them over so that I'm making a matrix. I'm saying my variables are I1, I2, I3. I'm making a 5 by 5 matrix. I'm then going to do the inverse of this matrix times the matrix 0, 0, 0, 0, -12. And it should give me my answer for I1, I2, I3, I4, and I5. But if you guys have a equation solver on those new TIs, do it. I hadn't even thought of that. I'm instead going to make a superimposing matrix.
Yeah, it's got it.
5 by 5 matrix. Yeah, I know I've got one, but I don't. I guess do you all have simultaneous operators now?
Well,
Okay.
yeah,
I got my I'm doing the matrix.
Oh, you're doing this matrix. Okay.
Yeah.
5 by 5. And I'm going to go 0, -1. You have a simultaneous solver on there. I've never played with it. 1, 1, 0, 0. I've got 1, 0, 1, 1, 1. Applies one of these is backwards, which I did not anticipate. Did I get a minus sign wrong? Crap. That should be a negative here. Hold on.
So that's 6, 6, -9.
I messed this up. This should have been -1.